Hi, it's Kiffin Bates here, and I was looking back over the previous videos in the series and realized that if you don't know what a cryptographic hash function is, then it's all going to be gobbledygook. So I thought it might be a good idea to back up and actually do a little video explaining what cryptographic hash functions are, because they are very important in the blockchain world. So in order to explain what a cryptographic hash function is, I first need to explain what a hash function is. And a hash function was invented in order to provide faster indexing and search capabilities in the digital world. Now, an analogy for a hash function is looking at, for example, cars and number plates. You have a car, and every car has a number plate on it, and cars come in different sizes. You might be driving a Mini or you might be driving a Bentley, but in Finland both those vehicles will have a number plate with 3 letters and 3 digits provided by the Finnish traffic authorities, and no two cars will have the same number plate, and that is ideal. And as a result, if you see a car and you need to report it to the police, you don't describe the make and model and colour and the damages and dents that it had in it and stuff like that. You just provide them with the number plate, and then they can go and look up what car it actually was and who owns it and stuff. So that's an example of a hash function. Remember, takes an input of any size and gives you a fixed length output. And the idea is that it's going to be what's called collision resistant, that 2 different inputs should have a very low probability of having the same output. And with number plates, the idea is that collisions are 0. There's no chance of having them. So the other thing that a hash function has to have is that it's very quick to compute, because you're doing search and you want the whole process to be as fast as possible. Now, a cryptographic hash function is slightly different, because there you don't want it to be quick to compute, because you want to prevent brute force attacks. So the idea there is that the cryptographic hash function takes a while to run. You can do one in a reasonable amount of time, but if you wanted to do billions, then it would take you a long time. And the second thing that a cryptographic hash function has to have is that it's got to be irreversible. If you've got an input, say a text file, then you put it through the cryptographic hash function and you get an output, which in SHA-256 is 256 bits. But if I give you a string of 256 bits, you should not be able to back calculate a text file that would give you that hash. It's meant to be one way, or sometimes it's called a trapdoor function. And then the final thing is that a cryptographic hash function is supposed to be effectively random. There shouldn't be a predictable pattern to it. You know, it shouldn't be that you get a certain output with this file, and if I add 1 character to the end, I get the next number up in the sequence. That would make it predictable and would give you a way of attacking it and reversing it. So the best analogy I've seen for cryptographic hash functions is, you imagine them as a magical elf sitting under a toadstool, and the elf has got a notebook and a pen and a coin. And you go to the elf and you give him your data that you want hashed, and what he does is he looks up your data in his notebook, and if it's not in the notebook, he tosses the coin 256 times and tells you the string of 1 and 0s that he produced back, and he writes your data and that string in his notebook. Now, if somebody else comes to him with the same data, he'll look it up in his notebook, see that he's already generated the random number of 1s and 0s, and he'll read that back. And technically he should also pause a bit for the time that it would take to toss 256 coins, so that the function has the same execution time regardless of whether the data has been seen before or not by this elf. So there you go, an analogy of cryptographic hash functions using a magical elf. Hope you found that entertaining, and I'll see you in the next video soon. Bye for now.